Before we do more with the strain and deformation concepts we talked about in the last video, we're going to look at some mathematical ideas in this and the next video. In this video, we're going to talk about what is a function and what does it mean for a function to be linear. A function can be thought of as a machine like this that takes an input and produces an output. The inputs are drawn from a collection or a set called the domain, and the outputs are in a set or collection called the codomain. For example, let's take the function f1 of x equals e to the power of x sine x. What is the domain? The domain is all real numbers, which we call R. And the codomain is also all possible real numbers, which we call R. In MATLAB, we would implement such a function like this. Now let's take another example. In this case, x has two components. So the domain is the real plane, which we call R2, and the codomain is all the positive real numbers. In MATLAB, we would implement such a function like this. Now let's take a third function as an example. Let A be an m by n matrix, and we define f3 of x as A times x. So x is an n by 1 vector, so the domain is Rn, and the output is Rm, the set of all m-dimensional vectors. Now let's take our epsilon log function as an example. The input is all the joint displacements, so it's a set of all vectors of size 4, and the output is all real numbers. Now let's see what a linear function is. So suppose there's a function x. For the input x1, it produces output y1, and for input x2, it produces output y2. Now for any scalar times x1, if the output is also the scalar times y1. So for example, if we double the input, the output also doubles. And if we add the two inputs, the outputs also get added. Then such a function is called linear. Which of the examples we discussed is linear? What I suggest you do at this point is pause the video, think about which ones are linear, non-linear, and then resume.